Okay, I'm going to go ahead and get started, ladies and gentlemen. There's not that many people here today. In fact, the number of people here today happens to be right now 0. And that's not a problem because I like to talk to myself. I'm just going to do this as kind of a quick video. I've got about 17 different computers running. I'm breaking the internet right now, and so we're going to give this my best shot. Hopefully my computer doesn't crash out. Oh, hey, there's somebody else. Awesome. I don't feel so alone. So today, if you're working on this, you're going to need quite a few different materials. This may be one of those lessons where you are kind of watching what I do because I've already built some of it already to get it done and get it started. And then secondly, might be something that you do a little bit of research about as well, because it's a little bit tricky. There are many different ways to do this, okay? In fact, you can research a bunch of these on the internet when we make solar outfits today. Now, today's not so great. I'm looking outside, it's fairly cloudy. You don't need a hot day to do this. You just need a sunny day. In fact, this would probably work in the winter. So what you'll need is you'll need kind of a flat box. Shoe boxes work great. As long as they're not too greasy pizza boxes work pretty well. You know, the longer and flatter they are, the better they work because they make a better hinge top. Okay, you're gonna need some black construction paper. You'll need scissors. You're gonna need aluminum foil. You'll need a glue stick or some kind of glue, okay? You'll need plastic wrap later. You'll need packing tape, the wide, heavy, clear tape or duct tape, and a lot of patience and time, because this doesn't work exactly like our normal ovens, but this is a good way to grow off the grid. So we're going to talk about heating things up using solar ovens. Okay, so I'm here by myself and it's great. I'm going to see if I can spotlight my video. I can't do that yet. Okay, so if you're here, you're with me, that's great. So when we do this, I'm just going to make sure people don't unmute themselves. Okay. This really deals a lot with conduction, convection, and radiation. Okay, I think a lot of you have talked about this. Okay, and this is just a good refresher. All right, when we talk about how particles move, we deal with conduction, convection, and radiation. This is a really good example because it shows an air conditioner here, it shows a stove here, and it shows this heated floor. When we talk about these three things, and I'll be honest, I get a few of them goofed up, all right? Radiate means to just spread out from the source, okay? So if you see a heat source, it's just radiating and spreading out. If it is convection, it's going in a circle. Basically, it's using warm air rising and cool air sinking. Actually, it's more of the cool air sliding underneath, the hot air kind of going up. It's got more energy, we think of it. And then you have conduction, and conduction is from one thing to another, directly touching each other. So that'd be like taking a very hot piece of metal, putting it in a fire, and then touching the handle. You're going to end up hurting your hand because it's going to burn. Pretty simple. I'm trying to find something that would have metal hand. That's a straight piece of metal here, but I don't. Not a big deal. All right. So radiation means spreading out. That's the heat, or that's what we can see kind of as those quote unquote heat waves. Convection is when we think about in our house, it's usually warmer upstairs and cooler down because cool air tends to fall and until it gets the energy to go a little bit faster, okay? And then conduction is directly from one thing to another. So if you put a pan on a stove and the pan hits the burner, that's conduction. It's directly hitting, okay? Kind of a neat thing to look at here. Stopping my share. My computer's a little slow sometimes. I like to show this one right here. Stop that one. Come on, computer. Come on. Here, it's thinking. It's thinking. It's thinking. May have stalled. It's great. Come on. Uh-oh. Uh-oh. Come on. There we go. There we go. Okay, got it. Oh, and I'm back to none. All right, all my friends left. I'll just keep talking to myself. That's great. Okay. Hang on, let me bring this up here. this to work, guys. It's being a little picky today. So if I jump here, this is talking about particle motion. It's easy to see. And when you have colder, the colder the particles are, they are, closer together, slowly bouncing off of each other. Don't go very far. As I heat things up and I add energy, notice the particles move faster. The easiest way to think about this is a bunch of 6th graders or 5th graders who are cold and don't really want to do any work. Okay, they just kind of all huddle around and, well, they don't do much if they're tired and they just kind of lump around. But then you start giving them more and more sugar and more Mountain Dew and make them believe that they are high on sugar, and they start bouncing around like a bunch of kindergartners on Mountain Dew and pixie sticks. Okay, it's pretty easy to see that. Okay, so when we use convection, the slower, colder air molecules, okay, so as we're way up high, we know that we get away from the Earth and it cools off. Well, as those molecules slowly lose energy and slide down, okay, they're going to lose energy. Some are going to gain energy. Energy is all about sharing, okay? We think of when we warm things up or cool things down, we're doing more of the heating and cooling. Well, the problem is, okay, we also get this backwards, okay? Cold doesn't cool down hot. Warm and hot brings up, warm and hot, which is all relative, brings up cold. It's all about sharing. Cold has low energy, hot has a lot of energy in excess. What hot wants to do is share and make everything equal with cold, so then it can be balanced. If I were to take this hot water inside a metal can and put it inside a cold water styrofoam cup, we would notice that the hot water temperature would go down and the cold water temperature would go up. But if I flipped places with this, I put cold water in the can and hot water outside, I would see that the cold water on the inside would go up and the hot water outside would go down, because that heat or the energy is being transferred through the metal can into the water particles inside. See, we get that backwards because we think ice cubes cool down our drinks, and they don't. The easiest way to prove that is to do that activity. Take a pop can, take a cup, fill it with ice cold water, put the can on the inside with hot water, and measure the temperature and watch what happens. Okay, the hot water won't stay hot, the cold water won't stay cold. Because if we thought that cold cools down hot, okay, as cold gives away its energy, it should get colder, and hot, getting more energy, should heat up. It's all about keeping the energy balanced, okay? So there is that, ladies and gentlemen. All right, a neat way to look at this, and I think some of you kind of did this if you were doing some of the different lessons that we did. The nice thing to do about this is to actually kind of do this little activity. The link is kind of up here, openscited.org, and it's gas particle motion. It's a really cool site. What it can show you is how fast these particles move, and when they start bouncing off of each other. I'm going to reset it here. I'm going to go to like 25. And right now our gas temperature is 200 degrees Celsius, which is, really, really hot. So I'm going to go to 100 degrees Celsius, which is boiling water. All right, we're going to reset it. Okay, so see, as we go here, eventually over time, it's going to do this. I like this visualize particle speed through different shades. And you can tell that some particles have less, okay, and some have more. Notice when they bounce off of each other, this dark one right here, if I follow that one, it changes. I'm going to follow, see if I can click on one. Let's take that one right there. We'll kind of watch that one. And when it gets bumped into, it doesn't have much. Notice, oh, look, it changed from white, which is going really slow, to much faster. And the other one, it collided with slow down. Here we go. It's going to collide again. Oh, it's gained energy. So it's sharing. Okay, it's getting transferred from one to another. High energy provides energy, slows down the other. Okay, kind of watch, boom. See if it hits a slower one. It's kind of bouncing there. This is a neat little thing to do, kind of a fun little activity. Change a few things. Notice that one picked up. It went from really slow to, oh, look, boy, it went from being very high energy to low energy. Whoop, now it's back to high energy again. It's going to bounce around. It's going to hit one of the slow ones. And notice it went from high to low. It's all about sharing. It's kind of wild. Okay, that's a great sight to look at. It's a fun thing to do. I wouldn't make it go too fast. I wouldn't get a lot of particles because it's going to be fairly hard on your system after a while, unless you have a really good computer that can kind of handle it. It gets to be a little bit tough. It gets to be a little bit, it just kind of like creates these streaks. You can watch the trails on them. You can watch a particle. And if you notice, I picked that one particle. It started with nothing or very little energy. It ended up being the one with the most energy for a while, and then it went back to slow, because the more energy you have, the more you share, and it all depends on collision, but we're not going to worry about that. So using these principles of conduction and convection and all these things, we can actually use these, and we can actually make ourselves go off the grid quite a bit with the solar oven. So in order to do this, what you're going to need is the things from the beginning, and you're just going to have to kind of follow these directions. We're going to cut our box to some dimensions. We're going to line the inside with black construction paper, because black, we know from our research, is good at absorbing the energy. Okay, we're going to glue foil to the flaps because foil reflects that, and then we're going to place the food on the inside. And when we place the food on the inside, we can cover it with plastic wrap to make a giant insulation and go from there. So today it's not so sunny, but it might work. We might be able to. So what I'm going to do is I'm going to switch over here. I've already kind of goofed it up there. I'm getting used to the new updated version. This one, okay, so I've got this done, and I'm going to kind of show you where I was. All right, so I started already by cutting. I took a box, and my box here that I took, I put all the flaps out. Okay, so I put all the flaps out, and I know it's already kind of done. This is just a prototype to show you how to do this. What I did is I took all the flaps out. All right, I folded this flap, front flap, in first. Okay, sometimes, I know when we did this in summer camp a few years ago, we actually cut these down and laid it out flat. You could do that. That would be fun. You could cut this out and lay it flat, or you could maybe, align it with foil and then bank it in if you need to. That's an idea. Okay, so I laid this flap down first. Okay, the one that's opposite this one, the one that is opposite this one, so like the top flaps, I put this one down first. I lied. Sorry, I lied. Okay, I actually kind of put that one down first. I cut it to a length right here in the front to kind of make it like a box. Then I took the two inside ones, okay, and I put those down, and then I cut them to make this square shape, okay, to kind of make an oven down and in, right? So what I've got is this. What I've got is this kind of oven inside. What I would probably do is, I didn't have enough black paper. I just was doing a prototype. I would line this side, this inside lip here, okay, with black if I left it like this, and then this side here with black paper. Now, I didn't even glue this down. You could not glue it down. You could also glue it down. You could put a cardboard base in there, all right? And I'm going to put black paper in here. Black's going to absorb my heat. It'll get nice and warm. So I cut these down. I took some packing tape I happen to have. Duct tape works fine. I put it here on this corner and kind of taped this corner down. So I taped this flap and this other flap down. I taped this flap down and this other flap kind of on top of each other, and taped them down and held them in place to make this like rectangular square box, kind of like an old TV. All right. And then what I did next is I took some basic everyday aluminum foil. Now, if you have foil tape, great, that's fine. If you have, actually foil tape might work a little bit better. I took basic, cheap, everyday aluminum foil. I just used a glue stick and I covered this entire area. Now I put mine down really, really fast. You might want to go a little bit slower, because the slower you can put this in here and the more you can flatten it down, the more you can kind of get rid of these air pockets. Okay, and the more you get rid of these air pockets, the flatter it is, the more reflective it will be. Okay, you might want to take a cloth, you know, and maybe shine it a little bit. If you have some polishing compound, you can always polish it. The shinier you can get this, the more reflective it is. And you can tell with my light in here, it's pretty reflective. It's not bad for aluminum foil. This is the thinner aluminum foil. You could always use the heavier aluminum foil. It'll hold up better. It may not be as reflective, okay? So notice I kind of pushed this down. I missed a few spots when I glued. I think I just had some areas that didn't stick. And I'm going to take my pencil or a spoon, and as best as I can, I'm going to flatten out all these ridges. And the flatter it is, the more it will reflect, you know, easier. Okay, I also kind of lined this side in here too. I was thinking, hey, if I have this here, I might have some extra light that banks in here and helps. The one tricky part about this one that I have here in my box, this flap is not as long as I would like it, okay? So it only kind of goes to about here. If I could, I would actually put a little bit more cardboard up here, maybe tape it to make this flap a little bit larger and taller so that I can bank it down in a little bit easier. Okay. So there's some, this is exactly where you would go, okay? Make it a little bit taller. That's why the pizza boxes are nice, because you can fold them up. They usually fold on the inside here pretty easily. They sit up nicely, and they're also nice and tall, and they're pretty flat and thin, and there you go. Some people I've seen have put like skewers or things to prop it up. That's fine. That works great. Another idea you could do, if you really want to heat things up, is you could build it kind of curved. By curving it, you're actually making the light become stronger and more powerful if you curve it, and you're actually kind of like centering it like a parabolic mirror. It actually kind of focuses the light in one spot, and you might be able to focus it a little bit nicer into your solar oven. All right, so I put a little bit extra back here, thinking it might be a wise idea if I'm putting this into the sun hitting here and bouncing off down in here. I might want a little bit on this back side just to make sure I get the maximum amount of sunlight reflected in here. Okay, so I've got my foil up top here. I put a foil backing here. You might have to experiment. Maybe you want to put foil here. Maybe you want to put black paper there. Maybe you've got a big lid. It'll work. Maybe you find that lining the insides of these, okay, these inside lips right here. Sorry, I can't see that very well. Sorry, guys. These inside lips, maybe if you line them with foil, maybe they're a little bit better. But I would think that you would want dark paper around these edges to hold in as much heat as you can. Okay, so then your next step would be to find a food to, sorry guys, I gotta find my plastic wrap, that is. Find a food to quote unquote cook. The best thing to do is to make a s'more. Okay, why make a s'more? Because they're easy and they don't deal with raw meat or eggs or anything. But what you will do is I would put a graham cracker here, a piece of chocolate on top, and then marshmallows on top, because that's how you make good graham crackers. All right, and put it in the middle here, maybe a couple. Or if you want to just start with marshmallows or chocolate, that's fine. Put it inside here. I might even put it on a piece of foil as well, or maybe even another piece of paper, because to keep our mess down. All right, then I will take some plastic wrap as tight as you can over the top, right? And this will hold the heat in. This will hold the heat in, and you'll make a really good seal. And me and plastic wrap, we don't always get along the best, but the tighter you can make it, the better it will be. Okay, so none of the heat escapes. And then what you will do is wait patiently. You'll find a place out in the sun. Now, it's not going to be the radiant heat from the sun that's heating it. It's going to be the reflecting of the light in here, sending it through the plastic, which is transparent, we can see through, And then it's going to cause all of this black paper to absorb the heat, okay, and warm up the internal temperatures. And now you may say, Patrick, how can that work? There's no way you can get enough heat to actually do this. And we measured this when we did this a few years ago at the camps. We actually showed that we started with an internal temperature of about 50 to 60 degrees. And by the time we had let them sit outside for, maybe an hour or two, which happens, okay, it's going to take a little bit of time, depends on how sunny. We were able to get the internal temperature of some of these to be somewhere around about 110 to even close to 150 on really well-designed ones that were in the sun. So yes, 150 to 200, you could get 150 to 200 degrees. If you look on the internet, there are all sorts of solar ovens that you could use. People who live off the grids use these quite a bit. They are effective. They do rely on dark colors absorbing light. And I know this was very fast. I kind of showed you how to do this. Go back, pause it, look at other examples, ladies and gentlemen. There are so many different ones, all right? So that is all I have for today. Just as a heads up, if you're watching this later, notice that's shiny off my screen. If you're watching this, we are going to start next Wednesday doing weekly science. There might have been some people who got confused. It is the end of the school year. We may or may not have quite a few people. I was hoping to say this to everyone, but we'll meet every Wednesday at 10 o'clock, and we'll do a little bit more complex science. Those of you who are watching this and you're going to join next Wednesday, 25 pieces of pasta, 25 small marshmallows. We're going to try to see how good of an engineer you are. So with that, ladies and gentlemen, have a great week. If I don't see you, have a great summer. Take care, everyone. So long for now.